Hey everyone, this is our lesson on acceleration, and hopefully by the end of this lesson you'll be able to understand acceleration by graphing and the calculations that you will need to know. So let's just start off by explaining what acceleration is. So this is the rate of change of velocity, and we learned about velocity in the last lesson. And this is a change in speed or direction. So you don't have to change both. As long as you change one of them, you are changing velocity, because remember, velocity is a vector quantity because it depends on direction as well. If the direction of motion does not change, then the acceleration is the rate of change of speed, which is normally what you come in contact with, especially like when you're driving down the highway or anything like that. You don't change direction. If you're on a straight shot, then acceleration is specifically due to the change in speed. So we do have to acknowledge our time interval here. So this is going to be whatever amount of time passes while that change in velocity is taking place. So we can calculate average acceleration, which is the one that we tend to deal with. So if I ever say calculate acceleration, it's going to be average. And you just take the velocity that you have and you divide it by whatever your time interval is. So you can see that in this little GIF over here. So we pick up the velocity, we have our time, and you divide it. You will find the change in velocity by subtracting final minus initial. So anytime you're doing a change, almost anytime, I don't want to say definitely, but almost anytime you're doing a change, it's going to be final minus initial. So here, velocity, whatever you end with minus what you start with. So here's our formula, just so you put that into thought here. Sorry, I had to do this a little differently because I can't put equations on here well. So acceleration is final velocity minus initial velocity over the time. And with symbols, it looks like this. So V final minus V initial over time. So let's go ahead and look at this practice problem. So from rest, which means a speed of 0, velocity of 0, a bicyclist accelerates to a velocity of 12 meters per second in the westerly direction for over 25 seconds. What is the acceleration of the bicyclist? So we know that our final velocity given here, so let me get my little pen out. Our final velocity was 12 meters per second. We know that we traveled for 25 seconds, and from rest means that we start out at 0. Okay. And like I said, our time interval was 25 seconds. So we want to know what the acceleration is. It's very easy to plug this in. You're going to do 12 meters per second minus 0 meters per second, because that's what our initial was, over 25 seconds. I know this looks sloppy, and that's just because of how I have to type these units in. When you do that, you come out to 0.48 meters per second squared, or you can see this as meters per second per second. So always do final minus initial. And then, let me X out of my picture here. It could be written as meters per second per second. So go ahead very quickly and try this example. Pause the video and try it, and we can go over it in class together if we need to. Oops. Those cleared off. So now let's talk a little bit about graphing. So when you graph acceleration, you are still using a speed versus time graph. And here, make sure you remember what your axes are. So your x-axis is going to be the time. That horizontal axis is the time. And then your y-axis or your vertical axis is the speed. And there are different types of acceleration that you could see on these graphs. So one of them is instantaneous acceleration. And this is the slope at any given point. So you would find it, and you'd find the line tangent to that, and you'd find the slope. So you could, hit a point in particular. At time 3 seconds, what was the acceleration? You also have a constant acceleration, which would be a positive slope. So that means as time and speed are changing together, you are increasing your acceleration. You have zero acceleration where your slope, zero acceleration. Your slope is 0, so that would be a plateau on your graph. And then you have negative acceleration or deceleration, and this would be a negative slope. So you're slowing down. And here on this graph, you can see, so we've got steady or constant acceleration. We've got steady speed, so that would be 0 acceleration, and then deceleration. All right, guys, so